All right, let's begin. And in previous class, we studied linear law. We covered the explanation of linear law, and we covered question number 1 of linear law, right? So today, inshallah, I'm going to cover some more questions of linear law because few questions were able to do it and few were not. So just to keep everyone on the same page, I want to cover few questions in front of me. So inshallah, I'll start from question number 2. So let's start. The variables x and y satisfy the equation y cube is equals to ae to the power of 2x. This is an implicit equation. We know that when equation is not in the form y equals to mx plus c, we have to take logarithms. We have to take LG or ln on both the sides to transform it into linear form. Over here, the examiner has told us the graph of ln y against x is a straight line. This means on vertical axis, we are going to take ln y, and on the horizontal axis, we are going to take x. The graph of ln y against x will be a straight line. The graph of ln y against x will be a straight line. So first, let's transform this into linear form. Then only we can sort out what will be the gradient of this line. Because the line will be a straight line, but what will be the gradient? The first part asks us to find the gradient of this line. To find the gradient, we are going to take ln on both the sides. अच्छा हम ln क्यों ले रहे हैं? Why are we taking ln and not lg? Because over here it's specified. I told you once, if nothing is specified, we can take lg or ln both. But if there's some indication regarding the usage of ln or lg, then we have to specifically take that. तो यहाँ पर क्योंकि इंडिकेशन मौजूद है ln y की, लिहाजा हम ln लेंगे दोनों साइड्स पर. अच्छा, अब कुछ बच्चे स्टेप्स भी शो नहीं करते. आई जस्ट वांट टू make sure that please follow the steps. Taking ln on both the sides. This is the first step. Even if you're not writing it, take ln on both sides. At least you have to, if you're not writing in words, taking ln on both the sides or taking logarithms on both the sides. So at least you have to show this step that you are taking ln on both the sides. Then you are splitting this as per the product law. All the steps needs to be shown. So look, ln y cube is equals to, now when ln is applied over here, we are splitting it using product law. ln a plus ln e power 2x. Then 2x will shift to the back. So 3 ln y is equals to 2x ln e plus ln e. Then we know that ln e equals to 1. ln e equals to 1. So ln e is 1, so it will go away. Over here, we will be left with 2x. And over here, we will be left with ln a. Then if we have to find ln, if we have to make ln y the subject, we are going to cross multiply 3 and send it to the other side. 3 को हमें दूसरी साइड भेजना पड़ेगा ln y को सब्जेक्ट बनाने के लिए, because we know that the graph of ln y against x is a straight line, so there has to be ln y on the left and there has to be one x, variable x on the right. So ln y is equals to 2 upon 3x plus ln a upon 3. अच्छा, यहाँ कुछ बच्चे गलती करते हैं, errors at times. When they divide 3, they divide by 2, but they forget to divide by ln a. जल्दी में at times students tend to do these mistakes. When they are in a hurry, फिर वो कहते हैं, sir, gradient has been, our gradient is perfectly fine, but we are not getting the value of a in the part 2. So because you have not written ln a upon 3. So make sure that you don't do any silly errors. Try to avoid silly mistakes. So if ln y is made the subject, then it is 2 upon 3x plus ln a upon 3. So the gradient is 2 upon 3. And this is the answer of part number 1. Why? Because on vertical axis, we are going to take ln y. On horizontal axis, we are going to take x. Our gradient is going to be 2 over 3. And our intercept will be ln a upon 3. तो gradient हमारा 2 upon 3, ये part 1 का आंसर हो गया. Part 2 में क्या कह रहा है? Part 1 completed till here, right? The gradient is 2 over 3. Part 2 says, find, given that the line intersects the axis of ln y. Axis of ln y. Now there are two axes, right? One axis is the horizontal and one is the vertical. So horizontal axis, on the horizontal axis, we are taking x. On the vertical axis, we are taking ln y. So cutting the axis of ln y. What is the meaning of intersects the axis of ln y? This means the other coordinate will be 0. So this means the points will be 0, 0.5. So we can substitute the coordinates of 0. We can substitute the coordinates 0, 0.5 in the equation of the line. Given that the line intersects the axis of L and Y at the point where L and Y is 0.5, find the value of A correct to 2 decimal places. You can also do one thing. You know that axis of L and Y is basically L and Y intercept. And from here, you know that L and Y intercept is L and A upon 3. If you are going to draw a graph of L and Y against X, then the intercept is Ln A upon 3. And over here, the intercept given is 0.5. This means Ln A upon 3 will be equal to 0.5. You can directly equate as well. मतलब direct equate भी कर सकते हो. लेकिन अगर आप ये नहीं कर रहे तो at least you have to pick the coordinates are x, L and y. And if the line is intersecting the axis of L and y, when L and y is 0.5, so this means x is 0. So the coordinates are 0, 0.5. So if I'm going to substitute over here, then in place of L and y, I'm going to substitute 0.5. X is of course 0. So 2 upon 3 times 0 will become 0. And Ln A upon 3 will be equal to 0.5. Cross multiplying 3 will make it 1.5. Ln A is 1.5. Now this is the log form. ये log form कहलाती है. From this form, we need to convert into index form. How to do that? कैसे convert करेंगे? We know that log ln means log to the base of e. So base is e, and on the other side we have power, and we know that a is the answer. So a is equals to e to the power of 1.5. So if we are going to calculate it and give the answer correct to, usually if nothing is specified, we give answers in 3SF, but over here it's specified. Find the value of a correct to 2 decimal places. This means we need to follow the instructions. This is a coincidence that 2 decimal places is same as 3SF, but over here, because it's written 2 decimal places, we have to specifically follow the instructions of the examiner. If nothing is written, then we could have followed the general instruction of 3SF, but over here it is specifically mentioned, so we have to follow that. I hope I've communicated this question. Note it down, and also acknowledge if you have if you are clear with it. Everyone's acknowledgement is required. Only then can we move towards the next question. Yes, is everyone clear? चैट पे बता दें. उबैद, शावेज. जी शावेज, समझ आ रहा है सवाल? एक्नॉलेजमेंट नहीं है आपकी तरफ से. अच्छा जनाब. Now this is a 5-mark question. Question number 3. The variables x and y satisfy the equation y is equals to a e power negative kx square, where a and k are constants. The graph of L and y against x square is a straight line passing through the point. चलिए जी resume करते हैं. Let's resume. So we were looking at question number 3. We already did question number 2. The variables x and y satisfy the equation y equals to a e to the power of negative kx square, where a and k are constants. The graph of ln y against x square is a straight line passing through the points 0.64, 0.76 and 1.69, 0.32 as shown in the diagram. Find the values of a and k correct to 2 decimal places. So now over here we have been given a graph and a sketch of ln y against x square. The graph of ln y against x square, and that is a straight line. So we already discussed before that over here we have x square and over here we have ln y. On the horizontal axis we have x square, on the vertical axis we have ln y. So the coordinates are not x comma y, but the coordinates are x square comma ln y. This is very important thing that you need to note. बहुत ज्यादा important है, इसमें बच्चे गलती कर देते हैं. मतलब वो they think that this first value is x and the other value is y, but that is not the case. We need to remember that the coordinates will not always be x comma y. The coordinates will depend upon what the axes are. So if the axes are x square and ln y, then this means that the coordinates will be x square comma ln y. The variables x and y satisfy the equation where a and k are constant. We have 2 points given. Now what's the next step? The first step is to transform this implicit equation into linear form. For that, we take ln or lg on both the sides, but over here we know that the graph of ln y is being displayed in front of us. So we need to take ln on both the sides. तो अब दोनों तरफ ln लेंगे and we have to write ln y is equals to ln a e power negative kx square. First step, taking ln on both the sides. So ln y is equals to ln a plus ln e to the power of negative kx square. Then as per the power law, minus kx square will come at the back. So minus kx square ln e plus ln a equals ln y. And we know that ln e is equals to 1. So minus kx square ln e plus ln a equals to ln y. Ln e becomes 1. It is ln y equals to minus kx square plus ln a. Now we see that the graph was ln y against x square, and we already see that after transforming the given relationship to linear form, we see that there is ln y and there is x square. Now what is going to be the gradient? The gradient is negative k, and the intercept will not be called y-intercept. The intercept will be called ln y-intercept, because on the vertical axis there is ln y. So the intercept will also be ln y-intercept. So this is the ln y-intercept is ln a. So if we need to find the value of minus k, if we need to find the value of k, what we can do? We have been given a graph and we have been given 2 coordinates. How to find the value of k? Can someone tell me? Participate करें और बताएं. k की वैल्यू कैसे आ सकती है? How can we find the value of k?
The gradient.
Gradient, yes. देखिए एक one participation is we can use simultaneous equations. Yes, that can also be done. If we substitute 0.64 in place of x square and 0.76 in place of ln y, then there will be one equation formed in terms of k and a. Then if we substitute another coordinates in the given equation, we'll get second equation and we can solve simultaneously. But this is one of the approaches. Another approach, which is a better one, is what Ubaid told us. Ubaid ने जो बताया वो ज़्यादा बेहतर है. क्या? We know after transforming that the gradient is negative k. and we have been given a straight line with two coordinates. So if we can find the gradient using these 2 points. So how can we find the gradient? Change. What is the formula of gradient? Y2 minus y1 upon x2 minus x1, right? But over here, there's ln y. So change in ln y, normally it's change in y upon change in x. But over here, it's change in ln y upon change in x square. So 0.32 minus 0.76 divided by 1.69 minus 0.64. So if we find the gradient equate to negative k, then that will give us the value of k very quickly. So this is what I have done over here. 0.32 minus 0.76 divided by 1.69 minus 0.64. I have found the gradient of the straight line using the two given coordinates. And then I've equated the gradient to negative k. So I'll get a negative value. I'll multiply it by a negative sign, and the value of k that I'll get is k equals to 0.41905. Although I had to give the answer of k in 2 decimal places. So even the working, it's always recommended the working has to be 2 accuracy higher than what the answer is. Then the accuracy of the working has to be 2 accuracy higher than the accuracy of the answer. So this is 691.64. Yes. Yes. So this is 0.491905. I have rounded it off to 5 significant figures. Although even if I would have rounded it off to 4 decimal places, that would have been sufficient because the answer was to be given in 2 dp. So we could have done our working in 4 dp. But taking higher accuracy, even more than this, uh, is never discouraged. If you want to take more accuracy, you can always take. तो मैंने ये accuracy ज़्यादा ही ली है, मसला नहीं है. Accuracy कम लेने में मसला है, ज़्यादा लेने में मसला नहीं होता. तो K is 0.41905 and we rounded it off to 0.42. तो एक सजेशन आई थी कि सर हम कोऑर्डिनेट सब्स्टिट्यूट करते हैं दोनों 1 by 1 and then we will solve the equation simultaneously. But another thing which is a better one is that once we have transformed in the form y equals to mx plus c, we can find the gradient of the straight line by finding out the change in ln y upon change in x square, and then whatever gradient we get, we equate it to minus k, and from there we'll get the value of k. Now when I have got the value of k, I can use one of the coordinates in place of x square comma ln. In place of x square, I can substitute one of the coordinates in place of x square and ln y, and then I'll substitute the value of k, but not 0.42. I will substitute the higher accuracy version over here, and then I will make ln a the subject, and from there I will be able to find the value of a. So 0.32 minus 0.7, we have got k, then we have substituted one of the coordinates. In place of ln y, I have substituted 0.76. In place of x square, I have substituted 0.64. 0.76 in place of ln y and 0.64 in place of x square. And the value of k, if I've substituted this, then it was minus k. So over here, it's minus 0.41905. Substituting k, substituting x square, substituting ln y. We are left with ln a only. Now we can make ln a the subject. So if we make ln a the subject, ln a is equals to 1.0288. Na is equals to e to the power of 1.0288. And from here, we are going to find the answer of a in 2 dp. So in 4 dp, it was 0.7959. Rounded it off to 2.80, correct to 2 decimal places. The value of a is 2.80. The bottom line क्या है भाई? First, we use the coordinates to find the gradient. सबसे पहले gradient निकालें. सबसे पहले ट्रांसफॉर्म करें इक्वेशन को ln on both sides लेकर. Once it's transformed, then you identify the gradient. अगर 2 points given है, उनको इस्तेमाल करके gradient निकाल लें, as we have found the gradient, sorry, over here, and then equate it to minus to find the value of k. Once you have found k, then you can substitute the value of k and one of the coordinates to find a. I think I have communicated it very clearly. note it down and acknowledge if everyone is clear till here. सबको समझ आ गई है यहाँ तक? प्लीज बता दें थोड़ा सा.
समझ आ गया सर।
Great. बाकी सब भी चैट पे acknowledgement दे दें. Is everyone clear? कैमरा भी मैंने खोल लिया. नेट का इशू का तो देखा जाएगा. अभी तो फिलहाल सही है मेरे ख्याल से. मूविंग ऑन टुवर्ड्स द नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 4. The variables x and y satisfy the relation 3 power y equals 4 power 2 minus x. By taking logarithms, show that the graph of y against x is a straight line. State the exact value of the gradient of this line. So, carry by taking logarithms on both the sides. Now, if it's not mentioned as to whether we have to take LG or LN, we can take any of them. Why? Because over here it's written the graph of y against x is a straight line. But then a graph of LGY against x is a straight line, or LNY against x is a straight line. Nothing as such is mentioned. This means we can take LG or LN both. We can also take any other log, log with a base of 2, log with a base of 5, log with a base of 50. We can take any other logs as well. But we know that when we have two options available on our calculators, one of them is natural log and one of them is common log, then why use other logs? So that is why we either use LG or we use LN, because we have a feature in our calculators and it's more convenient and better for us to use LG and LN. That is why we either take LG or we take LN. So when the examiner is saying by taking logarithms, we can take LG or LN on both the sides. And then we transform the given relationship to linear form. And then we can state the exact value of the gradient of this line. The word exact tells us that we do not have to convert into decimals. Very, very important. ये लफ्ज exact हमें बताता है कि हमें डेसिमल में कन्वर्ट नहीं करना, exact फॉर्म में आंसर देना. Right? So and then later on, carry the exact coordinate x coordinate of the point of intersection of this line with a line with equation y equals to 2x, simplifying your answer. तो अगर हम पार्ट नंबर 1 करते हैं सबसे पहले, तो ln on both the sides, ln 3 power y equals to ln 4 power 2 minus x. Then as per the power law, y comes at the back. 2 minus x also comes at the back. So it's y ln 3 is equals to 2 minus x ln 4. Then 2 will be multiplied by ln 4. Minus x will also be multiplied by ln 4. Minus x times ln 4 is minus x ln 4. And 2 times ln 4 is 2 ln 4. But over here we have ln 3 will cross multiply it. So ln 4 upon ln 3, and over here as well 2 ln 4 upon ln 3. Now I have rewritten it in the form y equals to mx plus c. Y is equals to mx plus c. And so it was the graph of y against x. So on the left side we have y. On the right we have x. And the gradient will be minus of ln 4 upon ln 3. So minus ln 4 upon ln 3 will be the gradient. And the intercept, the y-intercept in this case, because it was the graph of y against x. So the intercept is going to be ln y-intercept. Sorry, my bad. As there is y on the vertical axis, the intercept is going to be y-intercept. So our y-intercept will be 2 ln 4 upon ln 3. So the gradient is negative ln 4 upon ln 3. First transform into linear form, and then the coefficient of x will be the gradient, and the gradient will be negative ln 4 upon ln 3. So this is going to be our final answer for part number 1. So by first taking logs, convert into linear form, and then state the exact value of the gradient. Then part 2 says, एवरीवन टू अटेम्प्ट पार्ट टू, और बताएं मुझे पार्ट टू हो पा रहा है या नहीं हो पा रहा, कैसे जा रहा है। Calculate the exact coordinate of the point of intersection of this line with the line with equation y equals to 2x, simplifying your answer. पार्ट टू जरा ट्राई करें और मुझे बताएं आपका आंसर पार्ट टू का आ रहा है या नहीं। So I'm giving 2-3 minutes to you people. ट्राई करें और मुझे बताएं आंसर क्या आ रहा है। Once you are done, please share your answer in the chat, right? Yes, Shavis. Are you able to understand it? समझ आ रहा है कुछ, Shavis?
जी सर।
हो गया, आंसर आया? आंसर क्या आया हवीस? मानव, व्हाट आंसर आर यू गेटिंग? मानव, देखिए क्या करना है आपको. द फर्स्ट थिंग इज, get the exact x coordinate of the point of intersection. Exact. The firstly it's written exact x coordinate, right? So exact means that it should not be in decimals. Two students at times tells us that we are finding the equivalent answer in decimal form. Will that work? Not at all. It cannot work. It's specifically mentioned exact x coordinate is required of the point of intersection of this line with the line with equation y equals to 2x, simplifying your answer. So how can we do that? Y equals to 2x is one of the equations, and another equation is y equals to minus ln 4 upon ln 3 times x plus 2 ln 4 upon ln 3. So let's solve the two equations simultaneously. Whenever we have to find the point of intersection, we solve simultaneously, so we equate it. So 2x is equals to minus ln 4 upon ln 3 times x plus ln 4 upon ln 3. Now I'll discuss all the possibilities with you people. The first thing is ln 3 we see on in both the fractions. So even the LCM is going to be ln 3. So we can cross multiply. So minus ln 4 times x plus 2 ln 4 is equals to 2 times ln 3 times x. Then if we need to find the value of x, exact x coordinate, then we need to gather all the x terms together on one side. So 2 ln 3x plus ln 4x is equals to 2 ln 4. एक तरफ लेकर आ गए x वालों को और x को कॉमन ले लिया. Take x as common. Now 2 ln 3 plus ln 4 is equals to 2 ln 4. Now if we want to find the x, what we can do is 2 as per the power law becomes 2 ln 3 becomes ln 9, ln 3 square. 3 square is 9, so ln 9 plus ln 4. And 2 ln 4 is ln 16. ln 9 plus ln 4 is ln 36. And this is ln 16. If we need to find the value of x, so x is going to be ln 16 divided by ln 36. X is going to be ln 16 upon ln 36. Now the question is this in the simplest form? So over here, the examiner is writing the possible answers. X can be ln 4 upon ln 6, or it can be log of 16 with a base of 36. Now, change of base law is one of the laws of logarithms, which we have not studied in P3. However, as per that law, log of 16 with a base of 36 is same as LG 16 upon LG 36. And it is same as ln 16 upon ln 36. So if this particular answer is accepted by the examiner, then even ln 16 upon ln 36 would be accepted in this particular case. So ln 16 upon ln 36, whosoever is getting this answer, that is a perfect answer as per this marking scheme and will be awarded full marks. However, over here it's written simplifying your answer. So I will not recommend to give this as your final answer, because if there's something that we can do, we should do. If we can simplify, we should simplify. So although the examiner is not penalizing at this step, but if we need to give the simplified answer, then it is not recommended to give ln 16 upon ln 36 as the final answer. The question here is, how do we simplify? The first of the methods was, at this point in time, if we would have written ln 4 as 2 ln 2, The 2 ln 3 plus 2 ln 2 is equals to 2 ln 4. And if we divide, sorry, 4 ln, no, 2 ln 4, yes. 4 is 2 square, so it will become 4 ln 2. Then if we divide the entire equation by 2, then it will become ln 3 plus ln 2 plus 2 ln 2. Then we use the product law, it becomes ln 6, it is ln 4. ln 4 upon ln 6 will be the final answer. But the thing is that over here we saw the answer. Might be the students can say that we already knew the answer. That is why we could simplify. But let's suppose if we have found out ln 16 upon ln 36 as the final answer. And now if we are reading the question to simplify, do we still have time to simplify, or has everything ended now and nothing could happen? No, it's not like that. Much could happen if you realize that the answer can further be simplified. How? Now we know that 16 is basically 4 square and 36 is 6 square. So ln 4 square upon ln 6 square, and as per the power law, it will become 2 ln 4 upon 2 ln 6. Now we see that 2 and 2 can get cancelled, and the final answer will be ln 4 upon ln 6. Now there's nothing that we can do with 4, although 4 can be written as 2 square and it could be 2 ln 2, but 6 cannot be, we cannot break 6 any further, and nothing could be cancelled, and it cannot be simplified any further. Therefore, this is going to be our final answer. So if someone is following this entire working and giving ln 16 upon ln 36 as the final answer, it is accepted in this particular question, but might be because the question belongs to 2016. The examiners keep on changing, the mindsets do change. My marking scheme at times changes too. We have seen that few questions which were few errors which were previously ignored and marked as what we call that. There's a specific word, I'm forgetting it. Being lenient with. But the English word that was condone. Yes. condone. Usually the marking scheme uses this word. This means whenever the examiner has written condone, this means the examiner has been lenient in that regards and will be awarding you full marks for that, even if you have done something wrong. But at times, if this word is not written, then the examiner can penalize. So when the word simplified is written, then it's better to simplify as much as possible. So ln 16 upon ln 36 can be further simplified. 16 as 4 squares, 36 as 6 square. As per the power law, 2 comes at the back. 2 and 2 gets cancelled, and the answer will be ln 4 upon ln 6. X is equals to ln 4 upon ln 6. This is going to be our final answer. I hope I have made myself clear. Question 4 is completely done. Write it down and also acknowledge if it's clear and if you're done on chat messages. And if there's any further query or something you would want to ask, then you're more than welcome to do that. No, Arya. Why does the direct simplification not give us the correct answer? No, ln 4 upon ln 6 is the correct answer. No, ln 4 upon ln 9. ln 4 upon ln 6 is the answer. आलिया मुझे माइक पे बताओ क्या कह रही हो, क्या मसला है?
So when I simplified ln 16 over 36, I'm getting ln 4 over ln 9.
कैसे ln 4 upon ln 9? मुझे बताओ ना, स्टेप बताओ. कैंसिल कर दिया इसको, ln काट दिया क्या? 16 4 upon ln 9 क्या? 4 4 16, 4 9 36. ये किया है तुमने?
जी सर.
ये तो कर ही नहीं सकते. कभी भी कटता थोड़ी है ना, ln कटता है ना ln साथ नंबर कट सकते हैं. इट्स नॉट पॉसिबल एट ऑल. हो ही नहीं सकता ये तो. कभी भी नंबर्स नहीं कटते ना ln के साथ. ln 5 अपॉन ln 10 है, तो आप थोड़ी कहोगी 5 1 5 5 2 10 ln 1 अपॉन 2 ln 2, तो ln 1 तो जीरो हो जाएगा, तो 0 अपॉन ln 2 तो फिर जीरो हो गया. तो एक अच्छी खासी वैल्यू तो जीरो में कन्वर्ट हो गई. ऐसे थोड़ी हो सकता है, नॉट पॉसिबल. सिंप्लीफिकेशन का तरीका क्या है कि आप पावर लॉस से खेलें. आप बगैर लॉस के आप कैंसिल थोड़ी कर सकते हैं. ना एरन कैंसिल हो सकता है और ना नंबर्स डायरेक्ट कैंसिल हो सकते हैं. तो इट्स नॉट पॉसिबल दैट वी simplify directly by cancelling it, because this is a conceptual error. So what we can do is we can play with the laws of logarithms. 16 as per the power law. Sorry, 16 being the perfect square is 4 square. 36 being the perfect square is 6 square. As per the power law, it becomes 2 ln 4 upon 2 ln 6. 2 and 2 gets cancelled, and we get ln 4 upon ln 6 as the final answer. So we cannot cancel directly. I hope you have got it. What problem you were facing previously? Is it fine now?
Yes sir. So sir, if it's not a perfect square, then we can't simplify it further.
Yes, if it's not a perfect square, then we can't simplify it further, definitely. जैसे अब 4 perfect square है लेकिन 6 perfect square नहीं है. So even if one of the numbers is perfect square, the other one is not, we cannot simplify any further. Let's suppose if it's ln 35, then ln 16 is 4 square. तो 2 ln 4 अगर मैं कर भी देता हूँ तो नीचे तो ln 35 ही रह जाएगा, तो कैंसिलेशन तो नहीं हो सकती. तो मजीद सिंप्लीफिकेशन नहीं हो सकती. फिर अब 2 ln 4 छोड़ दो या ln 16 छोड़ दो, एक ही बात. But over here, there was simplification possible. That is why we have simplified it further, and we have given ln 4 upon ln 6 as the final answer. जैसा कि मैंने कहा, in this question, even this is going to be accepted. But you never know in future if simplified word is written, and because this is not the final simplified version, this can be simplified further. So, as per the requirement of the question, if we were to give the simplified answer, then ln 4 upon ln 6 was the better answer, was the most simplified answer. So we should give that. होता है ना कभी कभार वो लीनियंट होता है, फिर उसके बाद वो माफ कर देता है, लेकिन हमेशा तो ऐसा नहीं होगा ना. तो हो सकता है वो अब दोबारा ऐसा अगर सवाल आए तो ln 16 अपॉन ln 36 पे पेनलाइज करें. तो हमारी कोशिश होनी चाहिए जितना ज्यादा हम सिंप्लीफाई कर सकते हैं सिंप्लीफाई करें. ओके, आई होप इट्स क्लियर. क्वेश्चन नंबर 5 में मुझे कुछ डिस्कस करना है आप लोगों से. क्या डिस्कस करना है ये देख लो. टू वेरिएबल क्वांटिटीज, बस ये एक आखिरी सवाल करते हैं, उसके बाद एक्सपोजर इतना बढ़ जाएगा, क्योंकि आई गेस एज फार एज drawing of graphs is concerned, question 5 is the only question in which the examiner, I have compiled past papers from 2009 to 2022 October November. Even then there are only 10 questions of linear law. So you can estimate that if let's suppose altogether there are 65 or 70 papers, and out of that only linear law appeared in 10 papers, so how low the weightage is. Whether the weightage is low or high, we have to cover each and every area. That is why we are covering in very much detail. But the point is that out of those 10 questions, this question number 5 is the only question in which we have to plot the points and draw a straight line as well. Usually either a line is given and we have to find the unknown constants. But over here we have been told by plotting L and Y against X for these 4 values, draw a suitable straight line. So first let's read the question from scratch. Two variable quantities x and y are believed to satisfy an equation of the form y equals to c times a power x, where c and a are constants. An experiment produced 4 pairs of values of x and y. The table below gives the corresponding values of x and L and y. So we have x and L and y both, x 0.9 and L and y is 1.7. Now, how many values altogether? An experiment produced 4 pairs of values of x and y. The experiment produced values of x and y, but on the basis of y, we applied ln on all the values of y, and we have got ln y. Examiner is saying experimental values of x and y, but in the table they are giving, in the table the examiner is giving the values of x and ln y. Why so? So that we can plot x comma ln y. So if we are going to transform this equation to linear form by applying ln on both the sides, it's going to become ln y is equals to ln c plus ln a power x. Then as per the power law, x comes at the back. So ln y equals to x ln a plus ln c. Now we can see that there is ln y. We can see that there is x. So the graph of ln y against x is a straight line with gradient as ln a and ln y intercept being ln c. The examiner tells us by plotting ln y against x for these 4 pairs of values, so there are 4 points that we need to plot. So the grid is given to us, x on the horizontal axis, ln y on the vertical axis, and we have to plot these 4 points, 0.9, 1.7, 1.6, 1.9, 2.4, 2.3, 3.2, 2.6. If you are going to plot these 4 points on the grid below, and if you are going to join them, then we'll get a line. Now you know what? Whenever there are decimals involved and we have applied ln or lg on those decimal values, we have rounded it off to 1 decimal place. So is it possible that these values are exact? Not at all. If you are going to apply ln or lg on certain values, then we'll have to round it off. And there is always a rounding off error. Rounding off can never be perfect. This is very logical that rounding, whether you have done proper rounding or not, rounding off will distort the accuracy, and definitely the answer will not be as accurate as it should be because the values are not exact, they are rounded off. So now if you're going to plot these points, then we are going to notice that there is no straight line which passes through all 4 points. So if you have studied a topic named scatter diagram in your O levels in IGCSE, then you must have studied line of best fit. But in scatter diagram, the points were very scattered. That was a different thing. The points were scattered. There was a relationship between them. Over here, the points are not scattered. They are properly marked, but they are not lying on the one straight line. Because of rounding off errors. So if there are rounding off errors, then what we need to make sure that we draw a line of best fit. Now, one thing is we have to draw a suitable straight line. Line has to be a suitable straight line. Then also the word estimate is written. So whenever the word estimate is written, this means every student will get slight variations in this question. Everyone's estimate will be different. But the problem in marking scheme in this question is that they have given just one specific answer of C and A. And even they have not written any equivalent answers, or they have not even given the range in the marking scheme. Although when these types of questions used to come in additional mathematics in O levels or IGCSE, there was a big range that was given in the marking scheme, and that was actually perfect. That was perfectly fine. But over here, because this question might be the examiner gave for the very first time in 2017, I didn't see this type of question between 2000 to 2022. So this was the first question, and such question never came again. So might be that was the reason why the examiner himself was not able to prepare a proper marking scheme. However, if the word estimate is written, this means that answers will be varying. So it's not possible that you get C equals 3.7 and 1.5 only. You'll get you'll get other answers. It's possible that you get the right answer, but it's very, very highly probable that you get different answers. Because I've been covering this question for so long now that when I ask the students to solve it, every other student is giving us slightly different answer. And then they needs to be guided that this is a problem of marking scheme, that they have not given the range of the answer. Although this has to be a very serious concern, that if the word estimate is written, how is it possible that the students get this particular answer? Then marking scheme needs to write any equivalent answers will be accepted, or the answers should be in this range. So we don't need to worry. What we can do is we can recite Rabbi Zidni Ilma before we are attempting the paper. And then what we can do is we can plot the points 0.9, 1.7, then 1.6, 1.9, 2.4, 2.3, then 3.2, 2.6. So if we are going to plot all the 4 points, and if we are going to draw a straight line, then that particular line will pass the y-axis at 1.3. So it's possible that someone's line passes through 1.4, someone's line passes to 1.2, 1.25, 1.35. Different answers are possible. So what we have done is, first of all, I've converted it into linear form. ln y is equals to ln c plus ln a power x. Then x ln a equals to ln c. Sorry, ln y equals x ln a plus ln c. The gradient is ln a and the intercept is ln c, right? So if we have drawn a straight line, then you check out how do we draw a line of best fit. So when we used to learn making a line of best fit in O levels IGCSE, you were told that whenever we are drawing a line of best fit, we need to ensure that maximum number of points lie on the line. And if you're leaving certain points, then this needs to be ensured that there are equal number of points below and above the line. So over here, you can see that these 2 points, line is passing through these 2 points. One of the points is slightly below and one point is slightly up. And then we have drawn a line of best fit. So this is not going to be the only line of best fit. Definitely, there could be multiple answers to that. And unfortunately, over here, marking scheme has given just one answer. But ideally, everyone will get different answers because the word estimate is written. And inshallah, if any such question is going to come in future, there is going to be a range in the marking scheme. This is an error from the marking examiner side, that they should ensure that every such question has different answers, and therefore there has to be a range given in the marking scheme within which the answers should lie. But they go okay. Another thing that I need to tell you is that once I have plotted the line, then you know that the coordinates are x, ln y. So what the students usually do, they use the table to find the gradient, and they equate the gradient to ln a, because as per y equals to mx plus c, the gradient is ln a, but the x is x and the y is ln y. In place of y, we take ln y. In place of x, we take x, but the gradient is ln a. So now how to find the gradient? So for the gradient, we have 4 pairs of points given. But should we use any 2 points from this table? The answer is a no. The answer is a big no. Why? Because the question specifically mentions by plotting ln y against x for these 4 pairs of values. By plotting ln y against x for these 4 values and drawing a suitable straight line. First plot the points and draw a suitable straight line, then estimate the values of C and A. Without drawing a suitable straight line, you cannot estimate. This is what the examiner is telling you. And we have to give our answers correct to 2 significant figures. So first, we have drawn a line of best fit, which is a suitable straight line. And then when we are estimating, the answers will slightly vary. So if I've drawn a line and then extended it, I've got the ln y intercept being 1.3. And from here, the intercept is ln c. So I can directly write ln c is equals to 1.3. So ln c is going to be 1.3. So I've equated ln c with 1.3, and the e, if I convert from log form to index form, then c equals e to the power of 1.3, and if I calculate, it's 3.669, rounded off to 2 significant figures. Over here, the instructions is 2 significant figures. The specific instruction is not just give your answer, but the answer's accuracy has to be 2SF. For that, a working has to be more than 2SF, means it could be 4SF or 5SF. I have always recommended 2 accuracy higher. So now this is 1.3. I can equate 1.3 with ln c. 1.3 c equals e power 1.3, and the answer is 3.7. Yes, one thing I was telling you was, should we take for finding the gradient, should we take the coordinates from this table or should we use the points on the line? So because these were the 4 points that you have plotted, but few of the points does not lie on the line. So those points which do not lie on the line, you should not take the coordinates of that point. You should only take the coordinates of that point, of those points which lie on this line of best fit. So we can see that one of the points is 2.4, 2.3, and another point is 3.2, 2.6. 2.4, 2.3, 3.2, 2.6, and also we have found 0, 1.3. We have 3 coordinates. We can use any 2 coordinates to find the gradient. As after transforming to y equals to mx plus c, the coefficient of x was ln a. So ln a is the gradient. So if we find the gradient using 2 points, change in ln y over change in x, then it's 2.6 minus 2.3, sorry, 2.6 minus 1.3 upon 3.2 minus 0. From here, we'll get a as 1.3 divided by 3.2. If we convert from log form to index form, it is going to be a equals e to the power of 1.3 upon 3.2. If we find and calculate, we get the value of a, which is 1.5. The bottom line is that whenever we see such equations, the first step is to convert into linear form. Then we have to also ensure that how many points do we have to plot and whether the line will pass through all the points. So if it's a line of best fit, then it cannot pass through all the points. But if we are using any of the points to find the gradient, then we need to use those points which lie on this line. Because if certain points do not lie on the line, then there's a big problem. So we need to ensure that we only take those points while finding the gradient which lies on the line. So these are 2 points that we have taken and we have found the value of a. I think I've tried to communicate that we plot, we draw a line of best fit, and we find the coordinates from the graph, not from the table. Because this is what the question has instructed us to do. Take a screenshot and also acknowledge if question number 5 is all clear to everyone. Any doubts, anything that is disturbing you, please let me know. Alhamdulillah, we have been able to cover the first 5 questions of linear law, and I think everyone is clear. There's no problem. There are no problems altogether. There are 10 questions of linear law. I've already covered 5. Question 1 in the previous class, question 2, 3, 4, 5 in this class, and there are 5 more questions to do. So you can definitely complete them as a homework before the next class. If anything that is irritating or disturbing you, we can discuss that first, and then continue with the next topic. I hope I've cleared myself, and yes, alhamdulillah, everyone is clear.